Hello everyone, welcome to PM Networking. Hope you all are doing great. Guys, this is my topology for today. As you can see, this is the topology on your screen. And guys, this topology is bit different from the normal topology. Why? Why this topology is different? Because you can see I have same VLAN user connected with different router. Like PC1 is in VLAN 10, PC1 is in VLAN 10 connected with router number 1, and PC3 is also in VLAN 10 but connected with router number 2. In the same way, PC2 is in VLAN 20 connected with switch 1, and switch 1 is connected with router number 1. And guys, PC4 is also in VLAN 20 connected with switch 2, and switch 2 is connected with router number 2. So what is the problem over here? Let's understand the issue, what issue you will face in this topology while configuring this topology. And we need to set up a DHCP on router number 1. Let's say we need to configure DHCP on router number 1 for IP configuration, right? So that this PC can get IP address from the DHCP server. So we are going to enable DHCP on router number 1. But before that, you have to decide the subnet. What subnet you are going to use for VLAN 10 and what subnet you are going to use for VLAN 20. So let's say guys, for VLAN 10, I'm going to use subnet 192.168.10.0/24. Let's say this is my subnet for VLAN 10. So what I will do, I will configure one IP address from this network on router 1 interface, and guys will configure one IP address from the same network on router number 2 also. Getting my point? Let's say here this is physical interface. We have only one physical interface on router number 1, but this interface is connected with two different VLANs. So we need to divide this physical interface into sub interface, logical interface, one for VLAN 10 and one for VLAN 20. Fine. Let's say on VLAN 10 interface you have configured one IP address, that is 192.168.10.1. you have configured this IP address, and then you have configured the pool, right, for this network. In the same way, for VLAN 20 interface also you need to configure one IP, let's say 192.168.20.1. that means my subnet for VLAN 20 is 192.168.20.0/24. this is the subnet for VLAN 20. And guys, on router number 2 also I need to do same thing. I need to divide this physical interface into two logical interface, one for VLAN 10 and one for VLAN 20. And I need to configure one IP address on this interface and one IP address on this interface. So here on VLAN 10 interface, you will configure one IP address from the same subnet, from this subnet 192.168.10.0 network, right? That means this network information 192.168.10.0 network is directly connected on both router, like on router number 1 also and on router number 2 also. In the same way, 192.168.20.0 second subnet is also connected with both router R1 as well as R2. Then how you are going to perform routing between R1 and R2? And between R1 and R2, I am using this subnet 12.1.1.0/30, right? So if same network is running on router number 1 and router number 2, then how you are going to perform routing, right? So this is unique, and this unique features make this topology different. Okay, so without wasting our time, let's begin the configuration, guys. If you don't know how to configure this scenario, please watch this video till the end. Okay, because I'm going to configure this topology step by step. We will perform the routing, and then we will check these users are able to get IP address from DHCP server or not. Then we will perform the routing, and we'll verify end-to-end connectivity. Okay, so first of all, let me decide the subnet for VLAN 10 and for VLAN 20, guys. So let's say for VLAN 10, I'm going to use subnet 192.168.10.0/24, and for VLAN 20 I am going to use subnet 192.168.20.0/24. Fine. Okay, then I will create two pool on router number 1. So DHCP is centralized. Okay, we are not going to configure DHCP on both router. Okay, so let me access these devices. Here I have router 1. On the router 1, guys, first of all let me configure the IP. As you can see, between router 1 and router 2 I'm running 2L network. Okay, interface F0/1, say IP address 12.1.1.1 255.255.255.252/30. Then exit interface F0/0. On this interface only you need to run no such command, right? Because we are going to configure IP on virtual interface, on sub interface. So let me divide it. Interface F0/0 dot, let's say 10, and here I am going to say encapsulation protocol dot 1q for which VLAN, guys? For VLAN 10 dot 1q for VLAN 10. And then let me assign one IP address here, that is 192.168 dot, let's say 10 dot 1 255.255.255.0. Done. Then interface F0/0 dot 20, say encapsulation dot 1q for VLAN 20, and here I am going to define IP 192.168.20.1 255.255.255.0. Done. So IP interface brief. So you can verify the IP configuration on this router, guys, and so IP route. You can see both network 192.168.10.0 and 20.0, both network are directly connected. Fine. So here what we did, we configure one IP address on F0/0 dot 10 for VLAN 10, where IP is, guys, 192.168.10.1, right? Then F0/0 dot 20 VLAN 20, and here IP address is 192.168.20.1. Okay, then I need to create virtual interface on router number 2 also. So what IP address I am going to define on router number 2? See here, on the VLAN 10 interface I am going to define 10.2, and on VLAN 20 interface I am going to define 20.2. But subnet is same, right, on both router R1 and R2. Let me access R2 and let me configure the sub interface. Enable config T interface F0/1 first, IP address 12.1.1.2 255.255.255.0. You can verify the connectivity between R1 and R2. Ping 12.1.1.1. There should be reachability. Yes, you can see ping is working fine. Then, guys, on LAN interface only I need to run no such command, and I need to divide this interface into two parts. Let's say 0/0 dot 10. Here I am going to say encapsulation dot 1q for VLAN 10 and IP address 192.168.10.2 255.255.255.0. Exit interface F0/0 dot 20, say encapsulation dot 1q for VLAN 20, and IP address over here is going to be 192.168.20.2 255.255.255.0. Done. So now you can check the routing table of R2. So IP route, see, guys, same 10 network 10.1.1.0/24 connected, directly connected on fast Ethernet 0/0 dot 10, and 192.168.20.0 is directly connected on fast Ethernet 0/0.20, and same network is running on router number 1 also, right? You can see this is R1. On R1 also same network is running on same interface, right? 20 network. Okay, so routing table of R1 and R2, see, looks same, right? 2L network is there, then 10 network is there, means 192.168.10.0 and 192.168.20.0. And in the routing table of R2 also you can see 2L network is there, then 192.168.10.0, then 192.168.20.0. Same network informations are there, right? Now I need to configure what? DHCP on router number 1. So let me access R1 again. R1, and let me set up the DHCP services here. So go to config T and interface, not interface, IP DHCP pool. Let's say name of pool is VLAN 10, VLAN 10, and here I am going to define what network, 192.168.10.0, subnet mask 255.255.255.0, and then guys default router 192.168.10.1. So see, for all user, default gateway is going to be what, 192.168.10.1. Means for PC3 also default gateway is router 1. For PC3 also router 1 is default gateway. Fine. Now next, IP DHCP pool VLAN 20. Here I am going to say network 192.168.20.0 mask 255.255.255.0 and default router. Router 1 is my default gateway for all user of VLAN 10 as well as for all user of VLAN 20. So 192.168.20.1 done. Now can PC1, PC2 get IP address from DHCP server? Let me verify it. Let me take you to PC1 and let me try to configure IP. So see 192.168.10.2 because switch is already configured, right? If I will show you the switch configuration, guys, see switch configuration, config T, sorry, so interface trunk. So you can see 0/1 which is connected with router number 1 is already configured as trunk, right? Then so VLAN brief, you can see fast Ethernet 0/2 is in VLAN 10. Fast Ethernet 0/2 which is connected with PC1 is in VLAN 10, means is in correct VLAN, right? Then guys PC2 means F0/3 is in VLAN 20. Okay, so VLAN and trunk configuration is there, guys, on switch 1. Okay, on switch number 2 also we can verify the VLAN and trunking configuration. So on switch number 2, enable and show interface trunk. Yes, fast Ethernet 0/0 is the trunk link. Encapsulation protocol is .1q. Status is trunking, and then so VLAN brief. So here you can see VLAN 10 fast Ethernet 0/2. That means PC4, sorry PC3. This PC is in VLAN 10. 0/2 is in VLAN 10, and guys fast Ethernet 0/3. See fast Ethernet 0/3. 0/3 is in VLAN 20. Fine. That means VLAN configuration on switch 1 and switch 2 is correct. We don't need to configure anything on switches. Now PC1 is able to get IP address from DHCP server. You can see PC1 have got one IP address, that is 192.168.10.2, subnet mask 255.255.255.0, default gateway 192.168.10.1. Correct? Correct. PC2, let me try. Yes, PC2 have also got the IP address 192.168.20.2. But guys, we have already configured this IP address on router 2, right? On router 2 sub interface. So we need to exclude this IP address from DHCP pool. Let me do one thing. Go to R1 and say IP DHCP exclude address 192.168.10.1. I have already configured on router number 1, and then 2 I have already configured on router number 2. Then 192.168.20.1 and 20.2, right? We have already configured these IP addresses on router. Now again, if I will request for IP address to DHCP server from PC1, let me check what IP address it will get. DHCP. Now you can see PC1 got this IP address 192.168.10.3, third IP address of this subnet, first subnet, right? Now PC2, yes, now PC2 have also got the correct IP address 192.168.20.3. Now can PC4 get IP address from DHCP server? Let me try. No. You can see this PC is getting IP from APIPA. Why PC3 is not able to get IP address, guys? Because of helper address. DHCP server is in different network, right? DHCP server is in different network. So we need to configure what? Helper address. So you will configure helper address on which interface? See what problem is happening over here. When this machine will request for IP address, it will generate one discover message where source is going to be 0.0.0.0, destination is going to be 255.255.255.255, right? PC will forward it to switch will forward it to router number 2. Router 2 will receive this discover message on which interface? It will receive on F0/0.10. Why? Because this interface is trunk interface, and whenever switch will forward traffic from the trunk interface, it will add one .1q tag, right? So with the actual discover message, it is going to add tag number 10, because switch 2 is receiving discover message on F0/2 interface, and this interface is member of VLAN 10. That means switch is receiving traffic of VLAN 10 and it is forwarding from the trunk link. So it will add one tag of VLAN 10. So tag number is going to be 10. And when router will receive the traffic, it will check the tag number and will came to know the receiving interface. Receiving interface is going to be what? F0/0.10, because on this interface you are running encapsulation .1q for VLAN 10. Okay, but as this is broadcast message, router 2 is going to drop it, right? Because router 2 is not DHCP server, it is receiving broadcast message, it will drop it. So if we will configure the helper address, then router 2 will forward it to router number 1. So let me do one thing, let me configure the helper address on router number 2. Config T interface F0/0.10, say IP helper address. What is the IP address of DHCP server? 192.168.10.1. Getting my point? I've defined the helper address. But what is the problem now? If router 2 need to forward the traffic to 192.168.10.1, router 2 will check the routing table, do so IP route. Okay, so destination IP address 192.168.10.1, subnet network ID 192.168.10.0. It will look up for the network ID in the routing table, and guys, in the routing table you can see 192.168.10.0 is directly connected, right? Directly connected on fast Ethernet 0/0.10. So router 2 is going to forward traffic from this interface only, right? And this is receiving interface. So what we can do here, we can configure a static route. We can configure a static route for this particular IP address towards router number 1, like this. See, here I can say IP route 192.168.10.1, 255.255.255. Let's say 255, and next of IP address 12.1.1.1. Before configuring this route on router number 2, if you want to see the packet, see if PC3 is requesting for IP address, what is happening? It have generated the discover message. This is discover message. You can open it. Source 000, destination broadcast, right? At layer 2, source MAC address is the MAC address of PC3 and destination MAC is broadcast, right? PC will forward it to switch is going to forward it to router, and router will drop it, right? Which message it is? This is ARP message, right? So router 2 have dropped the discover message. Why? Because route is not available towards router number 1. So let me take you to R2 and let me hit enter over here. Now if router 2 need to forward the traffic to 192.168.10.1, it is going to check routing table, so IP route. So you can see in the routing table this time I have one extra route for this IP address, for this particular IP address, right guys? If router 2 will compare destination with this network, so here it is matching subnet length 24 and here subnet length is 32. So subnet mask is matching, right? Here subnet length matching is 32, here subnet length matching is 24. So which one is best? Static route, right? Because this is available with /32. So now router 2 will forward traffic to 12.1.1.2 if router 2 need to forward traffic to 192.168.10.1, right? If router 2 need to forward traffic to this IP address, now router 2 is not going to use this directly connected network, right? So let me try to ping this IP address, ping 192.168.10.1. Am I able to ping? Yes, you can see ping is working. Ping is working. So what I am expecting now, PC3 can get IP address from DHCP server. Let me try again. Still PC3 is not able to get IP address. See. Now what is the issue? Now what is the issue? See guys, try to understand the problem. Again I am assigning IP address. See, PC3 have generated the discover message, right? It will forward to switch will forward to router 2. Here source is 0.0.0.0, destination is 255.255.255.255, right? It will forward to router 2. On router 2 interface, helper address is already configured, right? So it is going to modify the destination. So now you can see here source IP address is going to be 192.168.10.2, IP address of my interface, right? This IP address 192.168.10.2 and destination IP 192.168.10.1, right? And a specific route is available in routing table for this IP address, right? So router 2 will forward this discover message to router number 2 and source IP is 192.168.10.1. Destination IP is 192.168.10.2. Correct? Router 2 will forward it to router 1. But guys, router 1 is going to drop it. See, why router 1 have dropped this packet? Because when router 2 will generate, sorry, when router 1 will generate reply, source IP address will be 192.168.10.1, destination 192. Here on router number 2 in the discover message, destination is this one 10.1, source is 10.2, right? But when router 1 will generate reply, source is going to be 10.1, destination is going to be 192.168.10.2. So router 1 is going to check their routing table. It will look up their routing table. And guys, see the routing table of router 1 now. So IP route. There is one network 192.168.10.0/24 directly connected on fast Ethernet 0/0.10, right? So here this network is directly connected on different network, right? It is receiving discover message on fast Ethernet 0/1, right? But destination network is connected on fast Ethernet 0/0.10, right? So on router number 1 also we have to configure one specific route for 192.168.10.2 which is running on router number 2. So let me do it. Config t, then IP route 192.168.10.2, subnet mask 255.255.255.255, and next hop IP 12.1.1.2. Define the IP. Now guys, I am expecting that PC3 can get IP address from DHCP server. Let me try. Discover message will forward to switch 2, switch will forward to router 2, router 2 will forward to router 1, and this time router 1 will generate. This time router 1 is processing the traffic, right? It is going to generate one ARP. What is happening over here? Let me check it. Yes, now you can see PC3 app got the IP address, correct IP address 192.168.10.5. Done guys, 192.168.10.5. And same thing I need to do for VLAN 20, right? So when PC4 will request for an IP address to DHCP server, it will generate discover destination broadcast, router 2 will drop it. So first of all, we need to configure helper address. You can see PC4 is getting IP from APIPA. First thing, I need to configure helper address on router number 2, and then we need to configure a route for helper address. So go to R2, configure T, and interface F0/0.20, say IP helper address 192.168.20.1 DHCP address. Then I need to configure one route for this network for this IP address. So say IP route 192.168.20.1 255.255.255.255, and next hop IP address 12.1.1.1, right? And I need to configure one static route on router number 1 as well. Why? To send the reply packet, because when PC4 will request for IP address, it will generate discover again source 0000, destination 255.255.255, right? It will forward to router 2. Helper address is already configured on router number 2, so it is going to change the source and destination. Source will be what? 192.168.20.2 my IP address, and destination is going to be 192.168.20.1, right? And route is available in the routing table for this network towards router number 1, so router 2 will forward it to router 1, and when router 1 will generate reply, source will be 192.168.20.1, destination 192.168.20.2. so we need to configure this route for this IP address in the routing table of router 1. Let me do it. Let me access R1 again and say config T IP route 20.1.1. 20.1.1. Sorry, 192.168.20.2. Subnet mask 255.255.255.252, and next hop IP 12.1.1.2. That's it. Now I am expecting PC4 can also get IP address from DHCP server. Let me check. Yes, you can see now PC4 have this IP address 192.160.20.6. okay. Now guys, question is, can PC1 ping to PC3? Can PC1 ping to PC3? Let me try. Let me check. If ping is not working, then this is your task. Let me know why ping is not working and how to troubleshoot it, how you will fix this problem. Ping 10.1.1. Sorry, 192. Ping 192.168.10. What is the IP address of PC3? PC3 IP address is 10.5. So 10.5. See, request timeout. Request timeout. request timeout, and request timeout, right? But you can see both PC1 is able to ping their gateway, ping 10.192.168.10.1. Yes, PC1 is able to ping their default gateway. Can PC3 ping their default gateway? Let me check. Go to PC3 and let's ping to their default gateway. Who is default gateway for PC3? Router 1, right? So let me ping 192.168.10.1. Will ping work? Will ping work? Request timeout. Request timeout. PC3 is not able to ping their default gateway. Question is why? Because see guys, I am pinging this IP address 192.168.10.1, right? So source IP address is going to be what? IP address of PC3, IP address of PC3, and IP address of PC3 is, where is PC3? Here it is. IP config default gateway IP address 10.1 and my IP address 10.5. So PC3 IP address is 10.5, right? So when PC3 will ping their gateway source IP address 192.168.10.5, destination IP 192.168.10.1, correct? PC3 will forward this packet to switch 2 will forward it to router 2. Router 2 is going to compare destination IP address with their routing table. So router 2 will look up their routing table, guys. So IP route, and destination IP address is matching in two network, right? Here also, right? Destination 192.168.10.1. So this IP address is matching in this entry also and in this entry also, but here we have larger subnet length, right? So this is more reliable. So router 2 is going to use this route and it is going to forward traffic to 12.1.1.1, right? Means to router number 1. So router 2 will forward this traffic to router number 1. When router 1 will check their routing table, sorry, while replying, when router 1 will generate reply, source IP address will be 192.168.10.1. Destination IP address is going to be 192.168.10.5. So router 1 will check their routing table, and guys, in their routing table, this destination network will match over here. So IP route in this entry only 10.1.1. Sorry, 192.168.10.0/24, which is directly connected on fast Ethernet 0/0.10, right, on their LAN interface. So static entry is only we have this static entry. So if you will inject a route for 192.168.10.5, then definitely PC3 can ping to their default gateway, right? But it is not possible to configure one route for all user, right? So let me do one thing. Let me add one route here. IP route 192.168.10.5, say 255.255.255.0. And guys, as this IP address is dynamic in nature, PC3 have got this IP address dynamically. So this IP address will be keep changing. So you cannot configure route like this. Okay. So next hop 12.1.1.2. Done. Now let me ping from PC3 to default gateway. PC3 to my default gateway. Again ping 192.168.10.1, and you can see this time ping is working fine. This time ping is working. Now can PC1 ping to PC3? Let me check. Ping 192.168.10.5. No, still ping was not working. Why? Because IP address of PC1 PC1 IP address is 192.168.10.3 and route is not available in the routing table of router 2. Yes, main network is available, but that is on fast Ethernet 0/0.10, right? Not toward router number 1. So router 2 cannot forward reply to router number 1, right? So now guys, what is the solution of it? Hope problem is cleared. What is the solution? Let me know the process how I can now make reachability between these devices. See, one option is configure one route for a particular device. Like if PC1 want to communicate with PC3, right? PC1 IP address should be in the routing table of router 1 and router 2, as well as PC3 IP address should be there in the routing table of router 1 and router 3. Then also PC1 can ping to PC3, but this is not the practical way, right? This is not the practical way because IP addresses are again keep changing, guys, and you cannot configure one route for one user. Okay, so let me just do one thing. Let me make reachability between PC1 and PC3, and then I will wait for your reply. Okay, like what approach you will use to make reachability between these devices. So for now, if PC1 is not able to ping PC3, what is the issue? See, PC1 IP address is 10.3 and PC3 IP address is 10.5. So I can inject these two routes in the routing table of R1 and R2. Like router 1, on router number 1, what we can say? We can say IP route 192.168.10.5 255.255.255.255 right? And on router number 2, IP route 192 IP route 192.168.10.3 255.255.255.255 next hop 12.1.1.1. Now can PC1 ping to PC3? Yes. You can see now ping is working, but as I told you, this is not practical. So let me know the practical approach, guys. What approach here you will use to perform the routing. Hope this video was helpful for you. If yes, please hit on like button, guys. If you have any question, query, please let me know in the comment section. If you want more videos like this, please let me know in the comment section. Just type yes in the comment section, guys. I will get to know you want more videos like this, right? Okay, so just type yes, or I have learned from this video was helpful, so that I will get to know, yes, you guys are learning from this type of video, and it will motivate me to make another videos like this, and will upload many more in upcoming days. Thank you, thanks for watching. That's all for today. We'll meet soon in next video, guys. Till then, stay safe. Bye bye.